All right, welcome to finding the domain of functions defined by just an equation. Now, if the author asks you to, graph the function and find the domain and range that way, no, that's too much work. I've got a shorter technique for you. All you have to do is ask the following question. If you can have negative values, 0, and positive values in your x's in the function, then your domain is all real numbers. If something doesn't work, then you have a domain restriction. So for example, if we're given f of x is equal to x squared minus 5x plus 3, I have two x terms. I have x squared. All right, so this is how I'm going to ask this question. Can I square negative numbers? Yes. Can I square a 0? Yes. Can I square positive numbers? Yes. There is nothing limiting x raised to an integer power. Then the next variable term, we have negative 5 being multiplied to x. Can negative 5 be multiplied to all negatives? Yes. Can negative 5 be multiplied to 0? Yes. Can negative 5 be multiplied to positive numbers? Yes. No restrictions on that term. Can I add 3 to my negatives, 0, and positive numbers? Yes. These three terms, there's no restrictions. So my domain is all real numbers. All right. Example B. G of x is equal to x plus 1 all over x squared minus 4. Well, I'm going to kind of cheat. I've already recognized some things here. I've already done x squared up here. This x squared is the same. It's fine. Minus 5x to the first, that's x to the first. This term's fine. Adding 1, subtracting 3, just like adding 3. Plus 1, minus 4, same as adding 3. They're all good. What else is new here? The fraction bar. That's new. Fraction means to divide. Okay. Can I divide by negative numbers? Yes. Can I divide by positive numbers? Yes. Can I divide by a 0? No. We can never have the denominator with a 0 in it. Okay, we have a restriction. Take that denominator, this is where we don't want a 0 to be, and set it not equal to 0 and solve it for x. All right, well, to solve this for x, let's add over the 4. X squared cannot be equal to 4. Okay, so what values can I have for x? Well, to undo the power of 2, you take the square root of both sides. But you got to remember that my answer is a positive or negative. All right, remember back in the previous video when I talked about when y can't be written to an even power and it be a function? Well, because you'd have y equals this value, y equals the negative value, you would have two equations. That's not a function. So I have two possible values for x that will cause my denominator to become a 0. These are called a restriction. Now, this is what we call an implied domain. I'm implying that my domain is all real numbers except for a positive 2 and a negative 2. That's an implied domain. So if they give you the notation in my math lab, left parentheses x, a straight line, text box, then you can put in this restriction right here. If that comes up in your homework and you get confused, let me know. All right, they'll usually ask you for what values you can't have. X can't equal 2, and then you put in another one, x can't equal negative 2. Third example, h of t is equal to the square root of 3 minus t. What's different here? Okay, instead of x's, we have t's. Doesn't matter. Focus in on the t's. All right, t to the first power, just like x to the first power, no problems with that term. I can go 3 minus negatives, 3 minus 0, 3 plus negatives. Everything's okay. New symbol, square root. Different story. I can take the square root of positive numbers. I can even take the square root of 0, but I cannot take the square root of a negative number. So I cannot answer yes to all three questions. I got to know. That means I have a restriction. When you work with a square root or any even root, if they had a 4 on this ledge or a 6 or an 8, there's going to be a restriction. So we call this 3 minus t the radicand. You are going to set that 3 minus t greater than or equal to 0 and solve it for t. This will tell you all the t's, or if you're working with x variable, all the x coordinates you can have. All right? So the one thing I like to do is to make sure when I'm working with inequality symbols is to make sure my variable is always going to be positive. So since it's a minus t, I'm just going to add t over to the other side. And there is my restriction. Now, I know most of us like to have the variable first with inequalities. So 3 is greater than or equal to t is the same thing as if I flipped everything around. Make sure the inequality symbol keeps pointing to the t. It would be t is less than or equal to 3. That's my domain right there. T is less than or equal to 3. Or if the directions tell you to use interval notation, that's this notation right here. Left parentheses, negative infinity, comma 3 with a bracket. Why different symbols? If you can touch the value, if you can be equal to 3, then you give it a bracket next to that number. But I can't touch negative infinity. I physically can't go out there and touch it. If you can't touch it, it gets a parentheses next to that number. Now, back up here in A, all real numbers in interval notation would be left parentheses negative infinity. Oops, sorry about the sensitive mouse there. Negative infinity, comma infinity with parentheses around it. All right, part D. Another fraction. Fraction has a restriction. Square roots have a restriction. This is going to have two restrictions because you can clearly see I've got a division, so my denominator can't be equal to 0, and I have a square root. There's going to be a restriction on the inside of my square root. The top, nothing to worry about. It's the fraction bar, the denominator, and the square root in the denominator. That's a problem. Okay, so we got to take care of both of those. So again, we're going to set the radicand x minus 1 greater than or equal to 0 and solve it for x. So I'm going to add over the 1. All right, and notice that there's no equal to line because since the square root is in the denominator, I cannot be equal to 0. So this is a great trick question the author likes to throw at us. He's checking to see who is going to leave the equal to line underneath the greater than symbol. And when you write your domain in interval notation, who's going to put a bracket around the 1 and who's going to have the parentheses. All right, so please take note. Next example, capital G of x is equal to x over x squared plus 1. Again, we have a fraction. Immediately tell yourself the denominator cannot be equal to 0. So I take my denominator x squared plus 1 and I set it not equal to 0, and I'm going to solve it for x. I subtract over the 1. And wait a minute. X squared cannot be equal to a negative 1. Well, you know what? That's a true statement. Because every time you square a number, whether it's negative, 0, or positive, it equals a positive number. So there's no possible way for x squared ever to be equal to a negative 1. So therefore, I can't solve that. And therefore, technically now, there's no restrictions on my x. This denominator will never, ever equal a 0. If I square a negative number, I get a value that's positive. If I square a positive number, I get a positive number. If I square a 0, it's 0, but I'm going to add a positive to it. So this denominator will never be a 0. So my domain is all real numbers, or your interval notation, left parentheses, negative infinity, comma, infinity, right parentheses. Next example. Capital M of x is equal to, there's that square root symbol again, but this time it's in the numerator. And we got a fraction again over x squared minus 25. So again, the denominator cannot be equal to 0. And the square root up here, you got to have x plus 5 be a 0 or positive. No negatives on the inside. So we have two restrictions defined. Always do the denominator first. That's the most critical one. This is the numbers you can't have. Up here, we're going to find the numbers you can have. So x squared minus 25, set that not equal to 0. All right, let's add over the 25. That gives me x squared cannot be 25. Well, there's two numbers that I can have. X squared can be a positive 5 or a negative 5. So you take the square root of both sides. X can't be a positive 5 or negative 5. These are the numbers you can't have. You can have everything else in the denominator but those two numbers. Now for the top, you can't have a negative inside that square root. So the x plus 5 greater than or equal to 0 is going to guarantee me no negatives inside my square root symbol. So I subtract over the 5. So x is greater than or equal to negative 5. Whoa, wait a minute. Time out. There is an equal to line here. This inequality says I can be equal to negative 5. But up here, the denominator said I can't be equal to negative 5. So what we do is we think about, all right, let's draw a picture of this inequality. Think of your number line. There's negative 5. This says I can be equal to negative 5 and have everything else off to the right. That's what I can have in the numerator. But the denominator said, wait a minute, you can't have negative 5. And you can't have a positive 5. So where the negative 5 and the positive 5, think of these as instead of closed circles for a point, think of these as open circles. It's like they're an open point. I can't physically touch those two spots. So my domain, well, I have two intervals here. Negative 5 to 5. I can have everything in between. I just can't touch those numbers. So there's no brackets. They're parentheses. Then there's a second interval after the 5, from 5 out to infinity. So when you have multiple intervals, you will see this U-shaped symbol that stands for the union in between each interval. So I can have everything between negative 5 and 5, and I'm going to union that with everything greater than 5 out to infinity. The more breaks, the more intervals you have. Okay? Now, all these examples, the function was given. Now, sometimes there's trick questions. Your functions appear in a word problem, something that's going to happen in real life. So, for example, it says find the domain of the function A of r equals pi r squared, which represents the area of a circle with radius r. Well, as it stands, we looked at x squared and we said, oh, x squared can be all real numbers. But now my variable r represents a distance. It's the radius of a circle. That's a distance, and a distance has to be positive. All right? So you cannot have 0 for your radius. If you have 0 for a radius, you don't have a circle. There's no area. And I can't have a negative radius. That's definitely no circle. So here, my variable r for the domain has to be a positive number. So r is greater than 0. That's the inequality form of the domain. Or my domain D, in interval notation, is 0 to infinity. All right, and that's our third video for section 3.1.